just as we did for data sets. In addition to finding some kind of measure of center, which in this case is our expected value, which tells us what we expect to occur, we also want to know how spread out we are. In other words, how far out do the values tend to be from our expected value? And for that, we use the standard deviation. So if you take a look, this was the probability distribution we used in the last video. It reflects the probability of having a certain number of gigs on the weekend for a side hustle. So how do we get the standard deviation? Well, it's going to be similar to what we did before with data distributions. But as before, we're going to modify it for the fact that we have probabilities. So here's the formula. So let's unpack this because this looks just awful. So let's see what's going on here. But what we've got here is this is a sum, right? So each xi is an outcome, the value of an outcome of our random variable. So think about that as the number of gigs. So each xi is a 0, 1, 2, 3, or 4 in that example. The mu is the expected value that we talked about in the last video. In that case, that's 2.16. So this measure, this subtraction, which is what we do first, tells us how far each outcome is from the expected value. Now recall that we can't just average those because we'll get 0. So instead, we do the same trick we did in the last chapter. We take each of those and square them and then average them. But the way we do that is we square each of those deviations, but we have this weighted average we get by multiplying each of them by the probability of that outcome. We add up all the results, and that gets us something called sigma squared, which we call the variance, and then we take a square root to get the standard deviation. Typically, we can expect most occurrences to be either within one standard deviation below the mean, or below the expected value, or one standard deviation above the expected value. So let's use our gig example to unpack this. So with our gig example, the outcomes are 0, 1, 2, 3, or 4 gigs on a given weekend. The average, the mu, the expected value, was 2.16. So the first thing we do is subtract each of these, 2.16 from each outcome. 0 minus 2.16 is negative 2.16. 1 minus 2.16 is negative 1.16, and so on. And then, as the formulas told us, we take each of these numbers in this column, each of these deviations from the expected value, and we square them. That helps us get away from having cancellation that gives us a 0 in the sum. That's what this third column is. Now the next column is simply the probability from our probability distribution copied over here. And what we do in order to start calculating our standard deviation is we weigh each squared deviation by the probability via multiplication. So for example, for the outcome of 0, we take the squared deviation from the expected value, which is 4.6656 right here. We multiply it by the probability of getting a 0 value outcome, no gigs on a weekend, which is 12%, and the result in the contribution from this outcome is 0.559872. We continue in this way for each value, each possible outcome, finding the deviation from the expected value, squaring that deviation, and then multiplying by the probability. And we get all 5 of these terms. And then in the last column, we take those numbers and we add them all up. And that gives us sigma squared, which is our variance, 1.9216. But for our standard deviation, we take a square root, and that's approximately 1.39. So what that tells us is something about how spread out these data are, or this probability distribution is. So bottom line, we expect to have about 2.16 on average, 2.16 gigs per weekend over the course of the next year. And we expect most of our weekends will have between a half and 2.16 minus 1.39 and 2.16 plus 1.39 gigs, whatever those two numbers are. What do we mean by most? Well, it kind of depends on the distribution. We're not going to get too much into that in this course. In the next video, we're going to talk about how we use the expected value and standard deviation of in a normal distribution to calculate approximate probabilities, like what's the probability we have more than 30 or less than 30 customers, using the example from section 3.2.